Hello everybody. Today we are going to be looking at heating curves. And heating curves is important that you understand is not a chemical reaction, but in fact a physical change. And we're going to be looking at how water changes from a solid to a liquid to a gas. And throughout this process, heat is going to be constantly added to the system, and we're going to be analyzing how that affects the temperature. As the heat is being added, the temperature is also changing, and then once you get to the melting point, you can see that it starts to level off, and that is because it is reaching the melting point and it is starting to change from a solid to a liquid. And at this point there's going to be both solid and liquid, but once you get beyond this point, it'll start to only be a liquid and the temperature begins to increase, as you can see on the graph. The two numbers involved in heating curve is the specific heat capacity and the boiling point. The specific heat capacity is how much energy is required to raise 1 gram of the substance by 1 degree Celsius, whereas the boiling point is how hot it has to get before it turns into a gas. At the melting point, we'll be using the molar heat of fusion, and at the boiling point, we will be using the molar heat of vaporization. Now you notice that we've reached the boiling point, and it's similar to the melting point as it's changing from a liquid to a gas instead of a solid to a liquid. And you also notice that the flat portion of the graph is longer than the melting point was, and this is because changing from liquid water to gaseous water requires more energy than changing from solid to liquid water. And the final increase in the graph is just the increasing of temperature of the gaseous water as more heat is being added to the system. And that's going to wrap it up, and that is heating curves.